Assalamualaikum warahmatullahi wabarakatuh. This is our video for MassTransfer mini project. Our group member are Nurul Azira binti Ismail, Siti Nur Ain binti Ismail, Nur Hidayah binti Ismail, Nurul Hidayatul Husna binti Muhtar, and Nur Ain binti Muhammad Anwar. The objective for our mini project are to evaluate the characteristic of fatty acid, to study the process of continuous distillation of fatty acids, and to determine the mass balance of fatty acid. Okay, over 1000 different fatty acids are known, are natural components of fat, oil, and other related compounds. The fatty acid composition of fat and oil varies widely depending on the source. Coconut and palm kernel oils contain high amount of medium chain saturated fatty acid like lauric acid. For our mini project, we choose lauric acid as our substance. The first step in fatty acid production is the splitting or hydrolysis of the triglyceride molecules of fat and oil in the presence of water to yield glycerin and a mixture of fatty acid. Purification of fatty acid by distillation has been practiced for well over 100 years and is still the most common and most efficient means of producing high purity fatty acids.
As for this process description, distillation used was continuous distillation. A simplified diagram of this process is illustrated in figure before. The concept of this distillation is the higher boiling point will remain at the bottom product while the lower boiling point will evaporate and distillate at top product. Glycerin have been used as a solvent and lauric acid as a required product. Glycerin has lower boiling point than lauric acid, which is 121 degrees C, while the lauric acid is 173 degrees C. So the glycerin will distillate at the top pipe, while lauric acid will collected at the bottom product as the required product. The procedure of the process start with the preheated lauric acid feed enter through pipe into the distillation column. The reaction chamber are then heated at the bottom while reboiler as a heating medium. Superheated steam is introduced through top pipe to the condenser. The low pressure imposed in the reaction chamber and the high temperature of the feed cause the superheated steam to evaporate vigorously, resulting in an instantaneous distillation of the glycerin. The vapor are lead to the pipe heater condensed by the water-cooled condenser and collected in distillate top product, which is glycerin. At the bottom product, the evaporate material is withdrawn continuously through pipe, which can be directed by valve back to the heating medium until producing the required product, which is lauric acid.
So, in this mini project, there are main factors that enhance the production of fat. There's two main factors from our mini project. So, the first is reflux, where the reflux is used to control the top temperature, thereby control the purity of the overhead product. The amount of reflux compared to the product is known as the reflux ratio, where when reflux ratio is increased, the amount of reflux increase. In general, the higher the reflux ratio, the fewer the number of tray required for a given separation. However, too high a ratio may cause flooding in the tower, resulting in poor separating and causing the off-space product throughout the system. So the second factor that enhance the production of rate is temperature. Temperature will govern the purity of the product. The control of top temperature is discussed just now as reflux. Control of the feed inlet temperature and that of the reboiler are also very important. Again, if the feed and the bottom temperature are too high, too much heavy vapor will rise up to the tower and put side stream product of space. This condition combined with high reflux rate will again lead to the flooding and poor separation. Opposite condition can lead to liquid starvation across the tray, and again a very upset process will result.
For the material balance, the feed we assume the feed is 40,000 kg per hour. The composition for lauric acid is 90 mole%, for glycerin is 80 mole%. The mole fraction for feed be 0.2. For the top composition, for lauric acid is 10 mole%, for glycerin is 90 mole%. The mole fraction for the top is 0.1. For the bottom composition for lauric acid is 90 mole% and glycerin is 10 mole%. The mole fraction for bottom is 0.9. We assume that the inlet is 40,000 kg per hour. The average molecular weight of feed mixture is total feed mixture, which is for glycerin and lauric acid is 113.6 kg per kilomole. So we calculate the molar feed flow, which is 40,000 kg per hour divided by 113.6 kg kilomole, we get 352.11 kmol per hour. For the overall balance, F equal to D plus B, 352.11 equal to D plus B, and D equal to 352.11 minus B as the equation 1. For lauric acid balance, 0.2 F equal to 0.110 D plus 0.910 B as equation 2. We substitute the equation 1 into equation 2, that we get 70.422 equal to 0.10 times 352.11 minus B plus 0.90 B. We get B, total B is 44.014 kmol per hour. From the equation 2, we know that the value for B is 44.014 kmol per hour. So total D is equal to 352.11 minus 44.014, we get 308.096 kmol per hour.
In conclusion, as we mentioned before, the objective of the experiment were to evaluate the characteristic of fatty acid, to study the process of continuous distillation of fatty acid, and to determine the mass balance of fatty acid. The glycerin has been used as a solvent and lauric acid as a required product. Glycerin have lower boiling point than lauric acid, so it will distillate at the top part, while fatty acid will be collected at the bottom product as the required product. For the material balance, the top product glycerin collected, the flow rate is 308.096 kmol per hour. At the bottom product lauric acid, the flow rate is 44.014 kmol per hour. There are several factors that would enhance the production rate of the final product, which are reflux and temperature. When reflux ratio is increased, the amount of reflux increase. For temperature, we must choose the most suitable temperature by referring to the properties of the fatty acid used.
Okay, that's all from us. Thank you.